How would you describe a line on a blank paper? You might talk about its location on the paper, or the steepness or the angle of the line. The same concept applies to describing a line mathematically on a Cartesian plane. We have a few ways of mathematically describing the location of a line. Firstly, we could see where the line meets or cuts the vertical y-axis, which is called the y-intercept. Alternatively, you could take a point on the same plane from where the line passes through. However, there can be many different lines passing through the same point, as shown. So we cannot accurately depict a line without knowing its slope or gradient, which can be thought of as rise over run, or for the purpose of illustrating, even thought of as the direction where the line is pointing towards. So how would you find the slope or the gradient of a line? There are many ways. Pause the video and think of some. Okay, so the easiest method is when we know that a line passes through 2 points. We can calculate rise, which is the difference between the y values, and then divide it by the run, which is the difference between the x values of the points. If we do not know the points but know the angle that the line makes with the x-axis, we can use a little bit of trigonometry. We take the tan of the known angle, that is the angle the required line makes with the x-axis. As tan is opposite over adjacent, which in our case is the same as rise over run, we get the slope. Okay, now we have the location and the slope of the line. But how do we represent this in an algebraic equation so that we can easily perform mathematical operations on it? Again, there is more than one way of doing this. Let's take the simple equation y equals x. If we insert a coefficient of x, that is a number that is multiplied by x, we can see the gradient change, showing that the coefficient of x, which is denoted by m, is responsible for the change in gradient. Or more simply, the coefficient of x is the gradient. Now we have y equals mx. Is this our equation? I don't know about you, but one limitation I can think of is that the line is fixed to the origin, meaning we need an additional value in our equation that determines the location of the line. This is done by simply adding a number, usually denoted by c, to our equation, which is also our y-intercept. We have finally arrived at the golden equation given in textbooks, y equals mx plus c. Note that every line will have to have a y-intercept at some point. We cannot have a line parallel to the y-axis, or else the slope would be undefined and we would not have a y-intercept.